equations. So we're going to look at how to solve equations, and we're also going to look at how to solve inequalities. The process is very similar to each other. So if you think about solving equations and inequalities, when we want to solve an equation, kind of keep this in your mind. Don't move things until the left side and the right side are completely simplified. So you don't start moving things left or right until you distribute and combine like terms. Then you move like terms to the same side. Undo any addition, subtraction, get the variable by itself. It's the same process you've done. Then you have inequalities. Now inequalities, there's only one thing different you have to keep in mind. Does anyone remember what the one thing that's different about solving inequalities? Anything? Yeah?
You have to flip.
When do you flip?
Well, so perform the integral operation of the coefficient if you multiply or divide by a negative, flip the inequality symbol.
That's the only thing that's different. Is everything else is the same. Solve. Simplify, distribute, combine like terms, move terms from one side to the other. Except when you're solving for that variable, when you're removing the coefficient, if you multiply by a negative, you have to flip the inequality sign. If you divide by a negative, you have to flip the inequality sign. And then you graph. So solving is the same, but then you're graphing. And graphing you have to keep in mind when you use an open versus a closed circle. And then which direction do you graph? Do you graph left or do you graph right? So open would be if it's less than or greater than. Closed if it's or equal to. So when you first read a problem, you have to look, is it an equation or is it an inequality? Process is the same, it's just to make sure you don't miss one of the steps. So for this one, 34 minus 10w equals 6w plus 2. What's the first thing I'm going to do? Minus the 6w. So subtract the 6w. So I have 34 minus 16w equals 2. And then what? You got the variables on one side. Was the first thing you did. What should I do with that 34? Subtract it. So I'm going to put the numbers, which we call constants, on the other side. And now you divide. So negative 32 divided by negative 16, positive 2. Done. Not extremely difficult for that equation. Then we look at the inequality on number 2. So since it's an inequality, you have to keep in mind, I'm going to graph. I have to keep in mind open circle or closed circle, and I have to keep in mind, do I flip at some point? So what's the first step here I should do? Joseph? Subtract the 5x. Get the variables on one side. So x plus 3 is greater than negative 2. Keep going. Subtract the 3. X is greater than negative 5. So if it says if it's an inequality, graph it on a number line. So here's my number line. Here's negative 5. What type of circle? Open or closed? Open. Negative 5 is not included, so it's an open circle. X is greater than, so which direction do you go? To the right. And there you go. Number 3, my favorite one. Why do I like number 3? Yeah, but why do you guys not like number 3? Why? Well, forget about different denominators. Who cares? They're fractions. We'll just worry about one thing at a time, and the fact that they're fractions freaks you out. But why? Why do fractions scare you like they do? Just visually, it scares you, right? You can't tell me why. But you have to think. This is math. This is you have to get algebra. Get this in your head. I spent the first chapter trying to drill this into you guys. Is stop freaking out about something that looks complicated. Because all you have to do is break it into something easier. That's algebra. Take something hard, manipulate into something you know what to do. So if fractions freak you out, get rid of the fractions. That's your job. If you don't like the fractions, get rid of them. And you just have to learn, well, how do I get rid of fractions? Well, what's a fraction mean? What operation? What is it? You are dividing by 8. You are dividing by 4. You are dividing 1 by 16. I don't want to divide by 3 numbers. I'm only going to divide, I'm going to look at just one number. I have fractions, and who said they'd have different denominators? Okay, so what should you do? Now, when you add and subtract, you need a what? Well, you need a common denominator.
Yeah,
We need a common denominator in order to add and subtract, don't we? So just figure this out. What is the common denominator between 8, 4, and 16? 16. So what I'm going to do is I'm going to take whatever that common denominator is. I am going to forget about the fractions. I don't like them, so I'm going to use that common denominator to get rid of them. I'm going to take the entire equation and I'm going to multiply by 16. I don't like fractions. Mathematically, get rid of them then. And let's see what happens. When I distribute to the entire thing, remember when we did integers to fractions, you know you're dividing by 8, so the multiplying by 16 only goes to the top. So 16 times 1, now divide by 8. What? 2. 16 times 3, now divide by 8. Divide by 4. So 16 times 3 is 48. Divide by 4, what do I get?
12.
So minus 12x. 16 times 1 divided by 16. Which looks easier? Because I took something harder and I figured out how do I get rid of it. That's algebra, manipulating something you don't know how to do into something you do know how to do. Do you know how to solve this problem? How?
Subtract 2.
Subtract the 2. Negative 12x equals negative 1. And then what? And when you divide by a negative 12, remember a negative divided by a negative is a positive. So x equals 1/12. But if you were to go back, and I go back to the original problem, I say, do you know how to start this problem? No, there's fractions. But if I go back to here and say, do you know how to do this problem? It's easy. So take something hard, make it easy. You don't like fractions? Multiply them out. Get rid of them. Love fractions. Once you learn, that's it. They're easy to do. Number 4. Can I start moving things left and right? No. What do I have to do first? Distribute. Distribute the 4.5, and I even have to distribute on the right side as well. So I have 4.5b plus 4.5 minus 2 equals 4b plus 12. So 4.5b plus 4.5 minus 2 equals 4b plus 12. Can you start moving things left or right now? Now, technically, yes, you can. But I say don't do it until it's simplified. You're more likely to try and move something to the wrong area or combine it to something that shouldn't be combined, add to both sides the wrong number. Before you start moving, make sure the left and right side are simplified. Combine like terms. Now start moving. So I'm going to subtract the 4b. So 0.5b plus 2.5 equals 12. Subtract the 2.5 and divide by 1/2. And b is 19. So the point of that one is to get you to realize distribute, combine like terms, then start moving. The point of number 3 is to get you to realize if you don't like fractions, find a way to get rid of them. Which is as easy as what's the opposite of fractions? Multiplication. So look at number 5. I can work the entire problem with fractions if I want, but if you don't like working with them, get rid of them. So when I see this, x over 3 plus 2 is less than or equal to 4x minus 7, what do I do? You look at it, the part that stands out is the fact that you have a what? Fraction. So if you don't like that part of the problem, how do you get rid of it? Multiply everything by 3. If I don't like this and if I don't want to work with it, I can just change the whole inequality. Multiply everything by 3. So when I multiply by 3 and I bring it over to that first term, x thirds, the whole point of multiplying by 3 is because it's going to cancel out the what? It's going to cancel out the divide by 3. So I'm just left with the top, which is x. 2 times 3 is 6. Less than or equal to 12x minus 21. I mean, that looks just like problem 2 in a way, doesn't it? Don't have to distribute combine like terms or anything like that. No fractions. It's something that's a lot easier to work with. I would subtract the x. So 6 is less than or equal to 11x minus 21. Add the 21. 27 is less than or equal to 11x. And when I divide by 11, I'm going to keep it as 27 over 11 is less than or equal to x. But there's a problem with that. How are you supposed to write your final inequality statement? Never like that. Never 5 is greater than or equal to x or 27 is less than or equal to x. How should it always read? Yeah. The variable always needs to be on the left side. So the variable needs to be on the left, the 27 11ths needs to be on the right. And when I flip it, when I flip their positions, it's going to also flip the inequality. I mean, you think it opens up towards the x, it opens up towards the x. It means the same thing. So 27 11ths, is it an open or closed circle? Closed, greater than or equal to, left or right? Please say right. And there you go. It's not bad. If you don't like fractions, get rid of them. Distribute, combine like terms, solve. Look at number 6. I mean, that one looks bad, but I see a fraction. And that's to me what looks weird. I can deal with negative y, but y plus 6 over 7 I can't deal with. So what am I going to do? Multiply everything by 7. I don't like fractions. Let's get rid of it. Negative 7y is greater than or equal to. Now here's the part that someone in the other class asked. Good question is, when you multiply to the y plus 6 over 7, what do you get left with?
Y plus 6.
Y plus 6. The whole point, very good, is to eliminate the denominator. And multiplying by 7 eliminates the divide by 7. I mean, nothing goes to that. Just the top's all by itself now. Now, that's not bad. Negative 7y greater than or equal to y plus 6. So I would subtract the y. Negative 8y is greater than or equal to 6. Divide by negative 8. simplify the fraction, that's negative 3/4, but I divided the number on the bottom as a negative. So what do I have to do to this inequality? Flip it. And there you are. So I have y is greater than or equal to negative 3/4. Negative 3, sorry, less than or equal to. Closed circle, less than goes which direction? Who here learned that, by the way? The inequality symbol. If the inequality symbol points to the left, you draw your arrow which direction? Everybody learn it that way?
Mm-hmm.
Remember the whole shortcuts? Don't base your whole mathematical foundation on a shortcut, because what happens is next chapter, we start dealing with up and down. We start dealing with y's, and you can't think whichever way it points. You actually would get the answer wrong half the time, depending on what the slope I give is. So you have to start realizing what you're dealing with. So we're going to address that shortcut next chapter. But then we can apply it. We spent last year looking at, in Algebra 2, ACT stuff. Going over what are some ACT style questions to prepare you for. Because it's not just direct solve, direct solve, direct solve. Sometimes it's applying your techniques to something that's very simple but it's worded weird. You know, if 3 halves times 4x minus 8 plus 2 equals 8, find the value of 7x minus 3. So to do this, I need to know what's x. I mean, if I want to find what's 7x minus 3, I just need to know what's x. Well, how do I find x? What do I do here? Mia, what do I do? If I want to know what x is, where do I find it?
Well, probably in the first equation where you have what it equals.
Solve for x. If that's true, find x and then plug it into the other expression. So I'm going to distribute. You have 3 halves times 4x. So which one gets brought to the 4? The 3 or the 2? Just the 3. So I have 12x over 2, which is 6x. The 3 goes to the 8, and then I divide by 2. So minus 12 plus 2 equals 8. Combine like terms, 6x minus 10 equals 8. And then I just solve the two-step process. Add the 10, divide by 6. X is 3. So I have 7 times 3 minus 3. So 18 is my answer.
How does the distributive fraction symbol in parentheses? How did you get
How do I get this? The negative 12 here? Remember, it's the number on top is the one that gets multiplied in. And this fraction means you're divided by 2 at some point. So the only part that gets multiplied is the 3 to the 8, then divide by 2. The 3 to the 4, then do the division by 2. All right, if we look at what is the largest possible value for x, if 6 over x is greater than or equal to 3/4. Again, it's worded weird. But if I want the largest possible value, you're looking for one number. But if I have an inequality, I'm going to solve the inequality. But I notice that inequality has what? Fractions. Well, get rid of them. What's your denominator? 4. And what? X. So I'm going to multiply by 4x. Who cares the denominator is an x? You can still multiply by the variable. So if I take 4x to the first one, what's going to cancel out? The x. So you have 4 times 6. When I take 4x to the second one, what's going to cancel out? The 4. So I get 24 is greater than or equal to 3x, which means 8 is greater than or equal to x. Flip it around, x is less than or equal to 8. But I don't want an inequality. I want what's the largest number then. What is it? 8. So you're solving an inequality, but you're applying the skill of also thinking. And that's kind of where your ACT multiple choice questions will come in a lot for this. It's not just solve. You might have one of those, but it's going to solve and then apply that answer over here, or interpret that answer with this scenario for it. All right, we're going to do these last 3. I'm going to save the rest for tomorrow. Literal equations. Just really an equation with more than one variable. In Algebra 1, you're used to it with slope-intercept form. Solve and graph is what you did in slope-intercept form. In geometry, you're used to it with a bunch of formulas. You have base, height, you have all circumference, radius, diameter. So some things I do on the notes is I will put, if I see it on there or up here on the webpage, is purple math. If you just go to Google and type in purple math and then the section header, you will actually get really good examples and really good explanations. The main idea is solve. Same exact steps. If I want to solve for y, that means my last step has to be y equals. I need y by itself. So if I look, can't do that yet. Because that y has a 2 attached directly to it, and it has a minus 5x on the same side. So which do I get rid of first? The 2 or the negative 5x? Not the 2. You always get rid of any addition or subtraction first, don't you? When you're solving, you always move the constants to one side, then you take care of the coefficients. So I'm going to add the 5x. So 2y equals 5x plus 18. Now, still need to get that y by itself, so what do? Now you divide by 2. When you divide by 2, every number gets divided by 2. 5 halves x plus 9. Now it says y equals, so then you're set. Yeah. I think my son's soccer practice is canceled. And it would be fun to do that in soccer. Any soccer players in here? Fun. Now, spectator, awful. But when it rains or even it snows, it's the best games to play in soccer. But then you gotta watch it now when it's not the best to sit there and watch it. Solve for x.
Wait, was that the final answer?
Yeah. It's slope-intercept form. Solve for x. That means your last line is x equals. But the problem is my x is in a parentheses. In that parentheses it has a 4, it has a y. What do I need to do first? Distribute. I mean, the main idea is always distribute and combine like terms. 3 minus 12x equals 24. You need that x by itself. It has a negative 12 directly attached to it, and then it has a 3y term over to the side. Which one do you get rid of first? No, you never get rid of the coefficients, right? You may think about it. The last step is always multiply or divide by the coefficient. The first step is always to get the numbers to the other side that are not like terms. So minus 3y. So negative 12x equals negative 3y plus 24. If it's directly attached to it, that means that's your last step, because that's the last thing you have to remove. So now I do what with that negative 12? Divide it. And when I divide, I simplify. Negative 3 over negative 12 is 1/4 x. 24 divided by negative 12, negative 2. Sorry, 1/4 y. Did that last class too. So 1/4 y minus 2. Then the wording gets complicated. What is the value of x in terms of y and z? So in this case, what is the value of x tells you your last line has to be x equals. That's it. When it says what is the value of x, x equals. In terms of y and z mean you need a y and z on the other side. So I'm solving for which variable? X. The ones that are directly attached to it, that's your last step. That's the last thing you have to remove To get this all by itself, this is the last thing I have to remove. I need to get rid of that 2z first. By doing what? Subtracting it. So 5xy equals negative 2z plus 10. It's still not by itself. It has that, but there's no term there anymore. It has just the 5 and the y. How do I get rid of those? Divide by 5y. It's being multiplied by 5. It's being multiplied by y, so divide them both out. And that would cancel them both. So x equals negative 2z over 5y. 10 over 5 becomes a 2, and the y is on the bottom. So it's not different. If you go back to solving, the first thing you did was you moved any addition, subtraction over the other side. It's the same thing here. Move any of the addition, subtraction to the other side. The next part was then divide by the coefficient. The next step is then divide by the coefficient. For the homework, it would be problems 1 through 15.